Hey everyone, today is Wednesday, March 31st. We are still doing the same old. Um, I am going to give you your agenda for the day and then we're going to start. So, the first thing we're going to do is star warm up questions. We're going to do 4 of them. All right, and then you're going to email me the answers to these questions. I'm going to tell you exactly how you're going to do this for me in a second. So, what you're going to do is, or what I'm going to do is, I'm going to show the question on the screen. You're going to go through it with me, and then you will email me the answer that you pick. Okay, and I'll show you how to do the email in a minute. However, everybody's going to need their Chromebooks out and ready to go with the email in a second. So you don't have this, but I have this in front of me. What I'm going to do is I'm going to walk you through the question. So yesterday I walked you through the question and I gave you the answer. Today we're going to take a step back and I'm going to kind of give you I'm going to give less and less as we go along with these warm up questions and these star questions. Okay. So I'm going to have these up. If I go too quickly and you need to evaluate the question a little bit longer, pause the video, go back, look at the question, read it, because you have the video in front of you. You can read the question yourself. So real quick, this says the graph below shows the relationship between the number of dollars a worker earns and the number of hours they work. So I know, and hopefully you know, that the more hours you work, the more money you make. And that is what this graph is showing. It is showing a positive slope, saying that the more hours they worked, the more amount of money they earn. So here are the hours worked and here are the hours earned. It says, what does the slope of the graph represent? So technically we don't actually have to find the slope. We just have to understand what it's showing. And so just so we are clear, I am going to check to see that the slope is right here. It looks like a perfect little dot, and I do know that it's a perfect dot here at the origin. The reason I know it's a perfect dot at the origin is because 0 hours, you don't make any money. Okay, so you get $0. So it looks like in 20 hours, they made $160. So you kind of can take the slope of that, which remember we do rise over run. So 160 divided by 20 is, and I'm calculating it real quick so I don't make any mistakes, is 8. So what does the number 8 have anything to do with our problem, with anything we're doing here? Is it the number of hours worked it takes them to earn $320? Don't know. Is it the amount of money they earn per hour? Is it the amount of money earned at the end of 40 weeks, which is way over here? Oh, I see where they got the 320 from. And then the number of hours, or is it the number of hours worked per dollar earned? Interesting. Okay, so I think you can automatically eliminate 2 of the answers. It might be this one and this one, so A and C. They gave you the numbers for the very last point. They said that in 40 hours, you get 320. 40 hours a week is a normal work week for most people. Some people might work more, some people might work less, but that is the normal. And they earn 320. That doesn't tell us what our slope is, though. That doesn't tell us how much we're going up each hour. So what they were trying to do is trick you that that's how far they went, so that's what the answer that it should be. So I'm going to say no to A and no to C. All right, you get to choose between B and D. Okay, moving on to this. Next question. So this was number 1, by the way. This is number 2. Even though the numbers are off, it's because it's pulled from an actual STAR test. So I'm going to try to, I'm going to move this right there. Okay, so let's talk about this question. It says, we have a graph here. This graph looks like a line. It looks like it's linear and not any other thing. It says, which of the following are represented by the graph? So we have 4 different equations of a line, or so we think. And we got to figure out which one of them, which combinations of any of them are this line. are representing this line right here. So I do want you to see that these are all in different forms. Form number 1 is in y equals mx plus b, where we know, and I'm going to try, I think I'm getting better at this pen, guys, that is the m and that is the b, where this is the slope of the line and this is the y-intercept of the line. This one is in standard form, ax plus by equals c. Ooh, not doing very good. Never mind. Thought I was doing good with the pen. Okay, and I noticed that this one is not even in any linear form that we know. It's actually a quadratic function. So this right here, I know it's a quadratic function because if I did x times x using distributive property, I get x squared. And if I have x squared, I definitely have a parabola, a quadratic function. I'm trying really hard with this pen and it's kind of working and it's kind of not. Anyways, so anything with answer with a 3 in it is wrong. So I'm going to mark off B and C because that is a quadratic and this is a linear function. And then lastly, we have point slope form where we have y minus y1. Oh gosh, I'm trying, guys. I don't know if there's an eraser. Oh, okay. Well, hopefully you guys remember what's happening. Remember, y equals mx plus b. Here's the m, here's the b. We do not want this one. It is a quadratic function. This one is ax plus by equals c. Now remember, in ax plus by equals c, we can find the x-intercept, the y-intercept, and we can find the slope. And x-intercept is c over a. Y-intercept is c over b, and the slope is negative a over b. So I am going to give that one to you. This is for standard form of a line, which is this one right here. And the last one, I was trying to write it and then was going to erase some things. I think I'm doing okay. All right, it is y minus y1 equals m times x minus x1. What happens is this number right here is the slope. These other little pieces of the equation as x1 and y1, it is a coordinate. If you can find this coordinate 6, 2 on this line and it has the correct slope, this one is probably true. You're going to have to go through these two and see if they are true also. Yeah, so we said that this one wasn't right and this one wasn't right. Okay, so I'm going to leave the rest up to you guys to see which one is for sure. Actually, I do notice that both of them have number 4 as the answer. So this one must be true because I do know that 6, 2 would be 6, 2 would be right here, which is good. Remember, the negatives are actually part of the formula. They're not part of the coordinate. Okay, so you're just going to have to figure out between these two, which of these is the actually correct one for this line. All right, I've done enough. Moving forward. Oh, gosh. Okay, don't. You know what? Clear screen. Okay. Oh, there's the eraser. Okay, next one. I'm going to move this thingy again. All right, so this says, which table shows the same relationship as y equals negative x squared plus 3x? Now, here's the deal. As soon as I see x, oh, that was a big circle, x squared, this is a quadratic function. However, I do know, and it's just, you haven't been taught this yet, but I do know that it will look like an upside down quadratic function because of this negative here. Okay, that's coming up later in our quadratic function lesson. So since this is a quadratic function, we're going to have to do this a couple different ways because we're not going to be able to find a slope on these tables. What's going to happen is if you are face-to-face, that means if you are in my classroom right now and you have a graphing calculator, you can type this into the graphing calculator. I'm going to actually erase it so where you can see what's happening. You can type this into the graphing calculator, pull up those tables. Remember, if you don't remember how to pull up a table, ask somebody around you. They will be able to help you. Find which one is correct. If you do not have a graphing calculator, for your use right now, you're going to have to plug in the x values to see if you get the correct y value. This is what I mean. Let's try this one right here. And I am going to plug in a negative or a 1 right here in this spot. So I got negative 1 squared plus 3x, which is times 1. Okay, so negative 1 squared, negative 1 times negative 1 is a positive 1. And then plus 3 times 1 is 3, which gave me 4. So this coordinate right here is correct, which means that G is not right because it said it was supposed to be 1, 1. And H is not right because it was supposed to be, that one said it was supposed to be 1, 2. So the only one that is correct is this one and F. So you have 2 to choose from now. All right, moving to the next. This is question 3, remember. So here I go to the last question. You're going to have 4 questions today in your email, and I'm going to show you how to do that in just a second. Okay, the value of y varies directly with x. Which function represents the relationship between x and y if y equals 2 over 3 or 20 over 3 when x equals 30? All right, that's a bunch of mumbo jumbo just to say which of these is the correct equation for this stuff if it varies directly. These words are important right here. Basically, this just means that if we were graphing these, we would not have a y-intercept. The origin is where we would start. And basically, the easiest way to figure out and most of us will see this number and think of slope because our mind might automatically go to y equals mx plus b. And if your mind does that, that's great. We just know that we don't actually have a plus b in any of these. We only have a slope. What we're going to do is we're going to take the y value, 20 over 3, which if I calculate that, 20 divided by 3 gives me 6.6 repeating over 30. I'm going to take y over x. And if I get y over x, I will find our answer for our slope. Okay. That was me helping you on 4 questions. You had this question. Oh, not the pen. You had this question and this question. So this was number 1. This was number 2. This was number 3. And this was number 4. Okay. If you have to pause on any of these questions, please do so. However, I am going to put my pen down and show you guys what I need you to do. So if you open a new tab, go to your Gmail, and I'm going to show you actually how to email me. So press compose. You're going to compose. All right. You're going to say to Miss Garza. So if you do not know how to spell my name, it is Garza, and it is Marissa Garza. And then in the subject, just type warm up. And then I want you to put the date, because if I tell you that we're going to start doing these warm-ups and I have a bunch of things that say warm up, warm up, warm up, I'm not going to know when it's from. So warm up 3:31. All right. So you're going to tell me number 1, I thought was answer choice IDK. Don't ever put that. 2 is answer choice all of the above. Just joking. I'm not giving you any hints at all. And then you would do 3 and 4, and then you'd say send to Miss Garza, and then it pops up right there for me. Okay, so now that we have done this, I am going to give you the lesson for today. And it is going to be about parabolas. Notice that this one is an upside down parabola. We are actually going to be finding the axis of symmetry. All right, so yesterday we might have talked a little bit about the axis of symmetry. I'm going to move this somewhere that is out of the way. Kind of. Go right there. Okay. So yesterday we talked a little bit about the axis of symmetry in those notes, just a little bit. If we don't remember, an axis of symmetry is a line that's going to cut it exactly in half. So it's nice on this one because if we look at the y-axis on this parabola, the parabola is cut perfectly in half. And like if we had to fold it, it would fold perfectly like that, just like an axis of symmetry or a line of symmetry that we used to use in art. However, we now have two different forms of a quadratic function that we can use to help us graph or calculate anything. If you have a graphing calculator, you could graph these functions into your graphing calculator and find the axis of symmetry that way, just by looking. But this is how you do it without it. So first of all, if you are given the actual picture and you can find the line that goes straight through the parabola, which is the quadratic function, you can type this in as your answer. So I am going to move this here just a second. You can type this in as your answer. We don't want to say the words y-axis though. It won't register that. What we're going to have to do is anytime we have a parabola, our axis of symmetry is going to go straight up and down because the parabola is either going to be this way or it's going to be this way. And we're going to cut it in half with a vertical line. Vertical lines always say x equal whatever number it falls on the x-axis. So if we're looking at this vertical line right here, that would be x equals 8. That is the name of that vertical line if we drew a vertical line there. We did not draw a vertical line there. We draw a vertical line here at 0 on the x-axis. So I'm going to type x equals 0 and then press enter. Okay. If you were in my face-to-face class, we have done this IXL before, and you might have finished. Actually, most everybody didn't finish this one. We only got halfway through it, and that's for a reason. Because eventually in this let me do one more example. So this one, the axis of symmetry would fall right in here. That is literally the middle point of the line. It hits the vertex of the parabola. It hits the very, very smallest point, the minimum, and it goes through 6. X equals 6. So I'm going to say x equals 6. Okay. All right. That one would be x equals -5, just so you know. But I did not let you finish, or I did not continue you in class doing the axis of symmetry because we got two equations like this. This is going to be what the notes are about today. So real quick, if you have a piece of paper, not if you have a piece of paper, but you need a piece of paper in front of you, you are going to write down all of this stuff on a piece of paper. So first of all, cut it in half, title it axis of symmetry notes for quadratic functions, break it in half. One side is going to be standard form, one side is vertex form. Okay, write those forms down. If you need to pause right now and get those done. However, I'm going to move forward. Okay, so I think I have, I am going to be in here drawing. So vertex form looks like a normal trinomial. It's going to have a number here, here, or here. However, if you don't ever see a plus number at the end, that just means that C is 0. If you don't have a number here and it just has the number squared and then a number at the end, that just means that B is 0. And then same thing sometimes, for instance, on this example, you only have the x squared. That means A equals 9, and then there is no B and C. They both equal 0. If you were finding the line of symmetry from a standard form problem, you would take whatever is B, and then you would say negative B over A times C. So consider this one. We have no B, so we would have -0 over A times C, which is super weird. I'm going to do it over here. -0 isn't a thing, by the way. However, I'm just going to do it just for learning purposes. 9 times 0 is 0. And anything, honestly, if we would have done 0 divided by anything, we should have known that this was 0. Okay, so we're going to go in here and put x equals 0 and get the answer. All right, so remember that this right here is the formula that you will use to find the axis of symmetry. So this one, let's do this one. The A is actually a -1, so and the B, there is no B, and the C is 4. So you will start to find patterns every now and then the more questions you do. So remember -b, if I had no b, it was just 0. So I'm just going to put 0 instead of -0 since that's not a thing. And then a times c, so -1 times 4 equals 0 over -4, which we know just equals 0. The axis of symmetry is always written in a vertical line with an equation of x equals whatever number that we figured it out as. So x equals 0, which is the y-axis, just so you guys know. All right. If you get two questions like this is now written in vertex form. Now, a quick little summary of vertex form. It's called vertex form because it literally gives us the vertex. Remember that the vertex comes from these two numbers. So whatever number we have here and number we have here is the vertex, x, y. It's either the I am actually getting way better at this drawing thing. It's either that little minimum value up right there or this maximum value here. Those are the vertices? I don't know, from quadratic functions. So if I was finding this number and this number to find my vertex on this thing, it would be 2 and 7. And notice that this -2 is just like we have it here, minus h or whatever. Which means that the vertex of this one is 2 and 7. And what happens is if this was the highest or the lowest point, it doesn't really matter. All we know is that our axis of symmetry will have to go through the vertex. And remember, we always say x equals some number. And if we had this as our vertex, that is where we would have been falling on the x-axis. So it gives us the hint of the axis of symmetry by giving us the x value for where the axis of symmetry will fall. So the answer for this one would have been x equals 2. So you can write down the examples, write down my notes. It's going to help you in the future. I'm going to see if I can skip because I want to so this one, I don't even have to look. I don't have to do all of this work. I can just see that this was the x value for my vertex. So I'm going to say x equals 5. This one is just like the standard form stuff that we were working on earlier. I'm going to try to get, I already know this one is going to be 0. I want to try to get 1. Don't like that one either. That one's going to be x equals 6. See, I can just, I feel like you'll be able to start being able to see stuff. This is x equals 0. I want one specifically, x equals 0 again. You'll be able to see it that. Yes, perfect. Okay. This example here is here's my example. I need you to see that these two numbers are h and k. So we have h, we have k. Notice that this says a +2. In our original formula, it has a negative whatever number. So the only way they would have got that is if they would have done x minus -2 and created a plus sign out of that, which means that our x value has to be -2, and then this negative or -4 was usually a plus k, which means that this is also going to be a -4. So I needed to show you this type of vertex form equation to show you that this is how every now and then it just kind of throws you off a little bit because this is not a minus, it's a plus because something made it change. It was a negative, which made it change. So this answer right here is x equals -2. Remember, because our x value tells us exactly where that axis of symmetry is going to fall along on our vertex, on our quadratic function. So x equals -2, and we did it. All right. This is your homework. So the the IXL assignment. If you want to go into the search bar and type in GXL into the search bar, you just type it in, GXL. I press enter after I have it, and it'll take you straight to there, or it'll bring up a little thing right here. As long as it says GXL in the corner, you're good to go. All right, you click on it and you work. This will be a gold star. Weird. This will be a gold star assignment for you guys. So either you can just do the gold star and find the axis of symmetry, or you can type it in the search bar. Either one works for me. Okay. That is it for today. Let me check and make sure on my agenda that we did everything. Yep. All right. Well, that is it for me. I will make another video for you tomorrow. Bye, guys.